mathematical world of inferential statistics has been growing for more than 100 years. At odds with this trend is that the practice of including hypothesis tests as part of the EDA process is not commonplace. Probabilities, including the ubiquitous p-value, are like visualizations. They transcend language barriers and enable us to communicate aspects of the data in a clear and concise way. Not everyone thinks of probabilities as a fundamental part of EDA. Perhaps this is due to a lack of understanding, perpetuated by a tunnel-visioned focus on machine learning models. It may surprise some of you, but our beloved machine learning models are more a part of inferential statistics than many people think. This refers to what is under the hood when you run a fit method in scikit-learn. Just that has been the subject of many textbooks. Statistical inference is all around us, and this unit will start with the basics as seen through the lens of SciPy stats, moving gently into commonly used hypothesis tests. Like many of the subjects in this course, there's only time to cover the most important information, but it is the goal that you come away from this unit with a newfound understanding for the utility of using hypothesis tests during the EDA portion of the AI workflow. We will touch on Monte Carlo methods as they are a part of the modern landscape of hypothesis testing, but more time will be devoted to them in the next module. Statistical distributions are a basis for many of the tools in statistical inference, and we will ensure they are readily available to use for EDA. Let's say you have sales level data from a company. There are some number of sales each day on average. You should have as part of your EDA notebook a small section dedicated to calculating probabilities. This way, when you communicate the findings, you can make statements like, based on a Poisson distribution, there's an 80% probability of hitting some goal in the next month. Or, based on a geometric distribution, there's a 24% probability that we will have 10 or more sales. Maybe you have a good intuition for these probabilities when you make a plot, but chances are the individuals you will be communicating your findings with do not. And that is why using probabilities as a communication tool is so important. The p-value is another type of probability. It's the probability of finding the observed results, or more extreme, given the null hypothesis is true. It is also the common result from null hypothesis tests like the t-test, ANOVA, Fisher's exact test, and more. We will walk through a few of these examples. P-values cannot be applied readily to all situations, and their misuse is unfortunately a problem that plagues science still today. The two most common misapplications of p-values are through multiple testing and p-value hacking, and we will cover both of those subjects. Statistical inference can be done without a null hypothesis, and without a p-value for that matter, by setting up statistical models corresponding to a set of possible hypotheses. Then, model selection techniques like AIC and BIC are used to choose the most appropriate model. The case study that immediately follows this unit reinforces the objectives of the unit and will help bring to light the modern options when it comes to statistical inference in EDA.